Alright, hey guys, this is your video over characteristics of relations and functions. Hopefully a lot of this is review, but you do need to make sure that you are very comfortable with everything on here, this terminology. In this top area right here, make sure you fill in all these things. Hopefully, really what you probably should do is pause the video, fill it all in, and then check yours to make sure it matches, because this you should be able to do with no problem. So if you need to pause the video, do that real quick, and then replay it to work on the rest of it. All right, so here we're going to get into the vocabulary. Origin, just make sure you know where that is, 0, 0, and then the intersection, the origin is the intersection of x equals 0 and y equals 0. X equals 0 would be the vertical line that actually is the same as the y-axis. And y equals 0 is the horizontal line where it's actually the same as the x-axis. And then, of course, you need to know that, of course. So its ordered pair is 0, 0. Any ordered pair is always graphed in the order x then y. So it'll always be a horizontal movement then a vertical movement, which is, again, is opposite of slope. So be careful there. All right, if you need to pause, and write the rest of that in. All right, on the rest of this, we're going to start copying in what each term means. As you go through it, try to think on your own what everything means before you just blindly copy things in, because tomorrow when you come in class, I'm going to expect you to know what each one of these is. So a lot of this is review, so those ones that you already know, just review them, and the ones that you're not sure about, make sure you read over them 2 or 3 times. So the first one we're going to look at is a relation. Now, relation is a set of ordered pairs represented by a set of points, graph, or an equation. Now, relations can look like a lot of different things. This is just simply a sample. And the reason I use this for relation, reason they drew it the way it looks here and not like this, is because this is not only a relation, but it would also be a function. And they want to make sure that you understand that relations are just ordered pairs or a graph or whatever. It can be whatever. It doesn't have any specific rules as long as it has an x and a y relationship. Okay? So, a function is a relation, but this one isn't a function. All right, next one is domain. Domain is always your x values, set of x coordinates. And of course, it's always your independent variable. Make sure you know that. That's important. So on here, they had some points graphed. And so they came back and they plotted, they listed just the x coordinates. And notice they are in numerical order. They go from left to right. Okay, so that's domain. Again, if you need to pause because you don't have time, pause the video. I'm going to just keep moving though. All right, last thing here is range. Oops, hang on a second. Actually, move that up in there. Do this. Get rid of all my old marks. All right, range. Range is just the y coordinates. So again, they had all the same points listed as they did up here for the domain, but they listed all the y's. Set of all the y coordinates in relation, and it is the dependent variable. Make sure you know that. All right. Then for a function is a relation. So all functions are relations, but not necessarily all relations are functions. So make sure you understand that. Relation in which each element of the domain is paired with exactly one element of the range. In other words, x does not repeat. Okay, and again, this is review, so obviously it's important. Set of points in which x value only occurs once, and graph where any vertical line will only cross the line once. So remember, if you need to look at a graph, you can do that vertical line test. Okay, it should only go through it one time if it's a function. So that qualifies. Okay, pause there for a second. All right, the next one is discrete. This is one that's probably new to us a little bit. Discrete, make sure you know. It just means that your graph is not connected. They are individual points, okay? Not connected. Important that you understand. That's what discrete means. So you'll just have a list of ordered pairs, okay? Now continuous, it'll be a line or smooth curve, and it has an infinite number of points. In other words, they will be connected. It continues. Those you will connect. These up here for the discrete will be more like points listed, like we have up here. But for the continuous, if you're given a, those will be shown usually by a equation of some sort. So this equation up here, if I had to guess, you know, it's going to be y equals the opposite of x squared something, okay? This isn't the parent because it's moved up. It looks like it might be a little up and a little over to the right. So this might be, let me erase this. So maybe if I had to estimate, which I'm going to have to, if I put it in transformation form, looks like it goes over maybe, doesn't go over quite 1, so let's say it goes over a half. So if I'm going to the right, that's actually going to be negative half squared, and then it looks like it goes up. Well, this is 1, 2 here, and the vertex is here, so it's actually a little above 2, so maybe it goes up 2.5. Okay? But anyhow, the main thing, that's just a little review on quadratics. The main thing I want you to get out of that is to understand that continuous keeps going. Okay? And if you're given an equation, then you do connect the points. But you don't when you're given a list of ordered pairs. All right. Let's go to the next one. Okay. Again, if you need to pause, pause. All right, on this one, increasing just simply means that both the x values and the y values increase. So not only is this going to the right, but as it goes to the right, it goes up. So an increasing function goes up, left to right. Intervals in the graph when the function goes up from left to right. So we're going to look at where some of the graphs go up, and they'll go up for a little bit, and then they'll start to go down, and those would be 2 different intervals, and we'll look at that tomorrow. All right, let me pause there. Okay, the last one is decreasing. This is a sample. It could do lots of things. It could just be a line that came down. But this is a decreasing relation where the x value increases but the y values decrease. So if I go left to right, the x values will be getting bigger, but the y values are dropping. So that's what decreasing goes down left to right. Remember, pause when you need to. Okay. All right, guys, just to review. What I want you to do is pause the video and go back and find, well, I guess I can fill this one in for you real quick. If f of x equals 2x plus 3, find f of 4 and f of negative 1. So if I do f of 4, oops, sorry. So if I do f of 4 real quick, 2 times 4 is 8, plus 3 would give us 11, okay? If I do f of negative 1, I'm just going to plug negative 1 in wherever I have an x. So 2 times negative 1 is negative 2 plus 3. Negative 2 plus 3 is 1. So when f is f of negative 1, y would be 1, okay? So our ordered pair that function includes, in other words, that line would go through, would be the point 411. And over here, this one would actually go through negative 1, positive 1 if you graphed it, okay? All right, what I want you to do real quick is find h of 3 and g of negative 3 on your own. Okay, hopefully you got those answers. If you didn't, go back and look at it again. What I do want to do is go through this expression here real quick though, because we haven't actually done one like this. What we're going to do is we're going to plug this whole expression in for x, wherever there's an x. So we're going to use g, so we're going to use our g function here real quick. So I'm going to do g of a plus 1 equals, I'm going to plug all of this in for x. So I'm going to put parentheses around it, a plus 1 squared, because over here it reads x squared. So now it would be a plus 1 squared plus 2. It's been a little while since we had to do this. Remember that a plus 1 actually means a plus 1 times a plus 1 plus 2 on the end. So this is FOIL. I don't know if you remember FOIL, but we're going to do first, outside, inside, last. First times first is a squared. Outside times outside would be a times 1, which would be 1a or just a. Inside would be 1 times a, which is a again, or 1a. And then 1 times 1 is 1. So that takes care of the FOIL, and then of course we have the plus 2 on the end. So when I combine like terms here, I get a squared, doesn't have a partner, so it's just a squared. A plus a is 2a. and then normally be plus 1, but since I have this plus 2 on the end, I'm actually going to go ahead and add those together and get plus 3. So there's nothing I can do with that. There's nothing that will combine or factor out or anything. We're actually not factoring, we're going backwards the other way. So this is my final answer for that. We'll probably have one of those like a bonus somewhere. So make sure you understand how I did that with the FOIL. All right, what I want you to do is go ahead and finish this page 3 and 4, and tomorrow we will finish the rest in class. All right, y'all have a good evening.